sit.
Yeah, I'll sit next to you, Alex. Okay, cool. All right, well, welcome, guys. We're going to co-plan. Anyone want to start us off? And I can start us off in prayer. In the name of the Father, Son, Holy Spirit. Amen. Heavenly Father, we thank you for the break we just had. We pray you give us the wisdom and strength to finish the year strong, and today allow us to work together to help our students just be better students and for us to grow in our teaching. Amen. Father, Son, and Holy Spirit. And it's just team norms. Oh, what time do we have to be at, Alex?
Class ends at 9:40.
We got it. Okay. You want to keep us time?
We're at 9 o'clock right now.
Okay.
Clock's ahead.
Okay, perfect. And then we're all present. And okay. So I guess just quick. Part of my class, because I'm taking a class at Nursery. So this counts as like working as a team. They're doing kind of same thing, like teaching us how to collaborate with teams and things like that. So they asked us to share like the rationale for why we're doing this work. And it's based on research. So there's a quote from one of the readings we did that says, teams are effective when they result in improvements to teaching, they produce continuous improvement, and results in meaningful and satisfying experience for members. So when we're doing re-engagement lessons, we're trying to create this environment that produces that. And then, this is just my opinion, like, well, we're all here, 5 heads are better than one. And then, but 3 also. And then also just sharing student work with other teachers allows for more outside of the box ideas and solutions from different people. And then just overall, this practice helps us get better at co-planning and giving and receiving feedback. And then I'm just going to request, hopefully we have time, if not I'll send it to an email. There's gonna be a little exit ticket for this session just to help me. And Alex, Jordan already saw this, but this is basically like a way to describe effective like classroom environment or team discussions. And so they have like the y-axis is how deep is our like the questions we're asking, deep depth of inquiry. So one is if we're just related to like business and logistics, and then the highest depth of inquiry is if we're actually like planning things together and monitoring data and understanding. And then the x-axis, it's like what elements are we addressing out of the 3, which is students, teachers, and content. And so the idea is that all 3 elements of instruction should be discussed, like the student work, what the teachers are doing, and the content they're learning, which is in re-engagement, we kind of naturally do that. And this is what and so I guess we can start, and this is just from the SVMI training, like how to do re-engagement lessons. We've done it before, so I guess we can just go ahead and go. So I guess the first thing is we'll do it like we did last time where we divide it up. How many do you have?
I think I have 20.
5 each person?
We have 20 or 19.
Okay. 1, 2, 3, 4, 5, 6. I'll take 6. I guess I'll take 7. Yeah, one more. And then here, we can't write on these, right? Or we shouldn't.
Well, they're gonna get them back now.
Oh, yeah. Okay. Can I get some sticky notes?
Yeah.
So during this first 5, I'll put 10. I think we did it 5. Just rotate. We rotate like last time. Right? So we're gonna rotate, and then we're answering what questions do you see the most mistakes in, what common errors did you choose, and write any notes. Okay. Okay, Kevin. You can take
I didn't get much from that.
There was some late. Okay. Oh wait, who do I pass this to?
Oh,
Or how are you rotating? I guess.
who had these?
I have, those are mine.
Oh, so you and I switched. So,
I don't know.
and we're passing, or which way did you pass them? We're passing that way.
Okay.
I think I passed mine to Castro and you passed it
Yeah, I
to
got
me.
mine.
Oh, yeah, leave me out, okay. 2013, 21. Oh, okay, he labeled his. Sure. Wait, so Jordan, I gave you my notes. Facebook. Interesting. In school. Okay.
I've seen this. You've seen this?
Yep.
Yeah.
You did the same.
I think so.
Were those the ones we started with?
Yeah.
does it say?
Divide the product by 2.
Oh.
It's the first one I mentioned, division. Even though it's the same.
Okay.
It's rough.
So for number one, what was the correct answer? Just agree, and then they have to or disagree. Wait, I was confused about the question.
Yeah, I thought the question was kind of strange. I mean, I would think the answer is disagree because it's, I imagine it's getting at congruency, right? And so if all 3 sides of a triangle are like if you know the 3 sides of a triangle, then any other triangle is congruent to the original triangle by side.
Mm-hmm.
Catch with that.
What's that?
Is
Yeah,
the
you
first one getting at like, there's only one triangle up to congruency. There's only one triangle where all the sides are known, right? Because if you know one triangle and then you draw another triangle that may be like rotated or
Yeah, that's what I
reflected
did.
or something.
I tried drawing different triangles. I'm like, oh, it's just the same triangle rotated. I forgot about side.
Is that
But-
what? Is that what?
I think that was the
There's
purpose of that one, yeah.
Like even if you didn't know side, you could try drawing it and realize, oh, it's the same triangle. It's just rotated with the 13 over here.
Right.
Like even if you tried changing it, it's still the same triangle.
But then like,
But I don't think anyone tried
and
doing.
almost every student put agree.
Yeah.
But then for their explanation, I couldn't really understand what their thought process was as to why they said agree.
I think they didn't quite understand the question. Like this one said, because every triangle, like a right triangle isosceles has different length size, but it's still a triangle. So I think from their answer, I think they asked, can you draw different types of triangles with 3 lengths? But I think they missed the part that says, if you know all the 3 lengths, you can still draw it so the triangles are different. So I think if they would have reworded it to say, maybe if they were to reword it, like read it, like okay, I'm already thinking of solutions. But yeah, that one I think they just didn't.
I mean, your point about the question is that like the clause at the beginning refers to triangles in the singular, and then the second part of it refers to triangles in the plural.
Yeah.
And so I think it's kind of
Confusing.
confusing as to what they're asking.
Yeah, if they would have said, look at this triangle,
That's the answer.
can you draw different triangles? I think it's disagree.
They disagree by
Side.
side.
Yeah.
Um,
They
but
haven't
then-
learned side, right?
Yeah.
Oh, they have learned it?
Mhm.
Oh.
I think what might have thrown them off is when, like I told them it was a pre-assessment to something we were gonna learn before I handed it out. So they like disregarded everything from the last
I
unit.
think also this isn't how you see questions asked for side. You usually say like this triangle and this triangle, and you can
Was there any explanation that you saw a student
wrote like
that
side.
would be like maybe, or is that getting ahead? Like just
This one-
beneficial to like maybe.
I like
Try to
this
get
one
it
from
sort of
Rihanna. A triangle can be different lengths and sides and still have the same value just as long as it's 3 sides.
Yeah, that's probably the best one.
But I think what she's saying is you can still have a triangle, which is not true because if you add the 2 sides, they have to be, so, but
And what does this mean? Have the same value? The value, like the value
I
of
think
what?
she meant measure. That's probably what she was getting at.
Of the sides, like
Yeah.
3 sides all have the same.
potentially will draw a triangle just in a different way. Yeah, so maybe this one, but like, let's try it. Let's try drawing this triangle, 13, 20, 21, and see if we can create a new triangle, Like, how about, kind of like, I forgot about side, but I was like, oh, if I just draw it, I read this, I'm like, let me try it, and I'm like, no, it's the same triangle, it's just rotated. So they would be able to, I wonder if they can like, I don't know, I think that one would be a good like, how can we prove this wrong, like, is this always true, sometimes true, or never true? That would be a good one. Let's see.
Yeah, 'cause they all would agree.
I think they were just asking, can you draw a triangle with any 3 sides? That's what I think they understood.
I mean, yeah, and the explanation, like here's one explanation. From my perspective, I am looking at a regular triangle and a right triangle. It is possible to create more triangles from the original ones. Like I can't quite
I
understand.
think
what
she
they're
meant
getting at.
like you can draw more lines and create more triangles.
And
Yeah, because
then-
there was one, I think it was Mimi, she drew a line straight here. she started doing markings here, like, so she made 2 triangles, which is threw me off because that's actually what we're doing in the unit, triangle similarity.
Yeah.
Actually, no, maybe I do.
You see what they're doing?
Yeah, this person wrote, I agree because, oh no, what was it? I agree because you can have the side and make it into a different triangle, and then, yeah, they drew like
Another triangle inside of it.
not necessarily like the altitude, but something, and they're basically splitting this original triangle into 2 triangles, and I think a lot of them are trying to say that given this original triangle, you can divide it into 2 triangles that are not necessarily congruent, or something
Yeah.
to that effect.
Yeah, but I agree. This part that says, even though you might know all 3 lengths of a triangle, you can still draw it so triangles are different in shape. So if they would have said it, you can draw other triangles with the same sides that are different. And I'm like, no, you're still gonna get the same triangle. Anyways, that's the only one that I found that understood the question.
Okay.
Because everyone else is like, I think they understood the question differently. So yeah, I think anyways, the learning goal would be like side, triangle congruency, right? Like students will be able to recognize.
And for that one, I would say, because then for number 2, I think it goes into converse of Pythagorean theorem, and 3 goes into area of a triangle, right? So it's like all kind of 3 different.
Number 2, I think, is also just definition of a right triangle, because some of them didn't know. Someone defined it as something not a squared, b squared, b squared, or 90 degrees.
Some put 90 degrees. Some just drew it with the box.
Yeah, I
90 degrees.
I didn't see a single person
use a squared plus b squared.
Did y'all?
No. And again, because they're used to being asked find a missing side, but they've never been asked to use Pythagorean theorem to prove.
They might know, because a lot of them, when we talked about like the triangle congruency theorems, when they asked like what's a theorem, and I told them what a theorem was, and then they were like, oh, Pythagorean, and I'm like, no, like it's not Pythagorean theorem. So they know it. I think it's like some know it. I just think when they are told to do that, they don't know when to apply it.
Because I think most of the time they use Pythagorean theorem, as Rosario said, to find the missing side, right? Whereas here, you're using the converse of the Pythagorean theorem to say that if the 3 sides satisfy the equation a squared plus b squared equals c squared, then you can conclude it's a right triangle. And probably some students have never even
used that or done that before.
Done that type of problem.
Because I know, just thinking ahead, a lot of mistakes too is they try to use Pythagorean theorem for non-right triangles.
Yeah.
They do it for everything, for every triangle they see. So I don't think they can make that connection yet.
Do y'all cover not the Pythagorean theorem? Like not. I'm saying that our students familiar with Pythagorean theorem, but are students familiar with using converse of Pythagorean theorem to show something is or is not a right triangle?
Eventually, yeah.
But have y'all done that on this?
Nope.
It's like that's what you are doing.
Yeah.
Oh, so that's why you told them this is like a previous system.
Yeah.
And then some of them on 2, a lot of them put the question is it a right triangle? And they said no, because it doesn't have a 90-degree angle, which is correct. Like the answer is no, and then the reason is true, but it's not actually like, it kind of begs the question. They're not really answering.
How do you know?
I think they're more of like, oh, do I see the little box or not?
Yeah.
Just knowing how they think. That's probably
Which makes me think, do they know that you can measure a 90-degree angle? Like, how do you know exactly that it's a 90-degree?
I think I think a lot of them just looked here and said it looks 90 degrees and put the box in there. Okay.
Yeah, you see he added 2 more down. 2 more right angles down there.
But don't y'all do problems like this where then you set up like the geometric mean or whatever?
Should we focus on, those would be what, the access, core, ramp?
I know for sure, just thinking ahead, this would be really good to talk about, because even like once I teach the whole unit at the end, when it comes to the test, that's the one of like the 3 things that they struggle on. First, they don't know where A or B is compared to C. They can't identify like the hypotenuse, even though they know what it is. They can't identify for some reason.
The biggest side, like even if it's not labeled.
Right. So like, or if it's just like the whole mathematics behind it, like squaring it and then doing the math. Like for some reason it throws them off. I don't know.
Or even that you can use it to prove that it's
That's
a 90
right.
degree angle.
Yeah, and I mean this, I don't think probably a lot of students done problems like that, but it's not like an uncommon problem. I think that if you did a lesson on it and had students practice it, like at that point it'd be
Yeah.
pretty straightforward to be access, right?
Mm-hmm.
But for students that never seen it before, it's definitely not a point.
Are you
also
can
the
use
best.
pen here backwards? Right triangle. So right now I have two learning goals. Use side-side congruency to justify whether a statement is correct or not, and then I'll be able to use the Pythagorean theorem to prove whether a triangle is a right triangle or not. And then should we try one more, or is that good? Or out of those, which one do you think? Because this number 3.
On the back, I don't think anyone
Yeah, I think the
is
back
way
is,
too-
yeah.
Number 3, basically getting at to find the area of the triangle is, you know, 1/2 base times height.
But the height has to be.
Yeah, but the base and height have to be at right angles, right? And so you can't just use any 2 legs of it because it may not be a.
Yeah, the base is the length of one side, but the height is the side of the triangle, it's a right triangle. Not true for non-right triangles.
Yeah, in a right triangle, the 2 legs are the base and the height because they meet at right angles. But in a non-right triangle, the 2 legs are not necessarily the base and the height, so you can't multiply them together. But no one even got, like no one mentioned even
was
close.
even close. So I'm
Some
assuming
of them
they
were
had to
saying the
get-
formula's wrong.
So I feel like
1 and 2
1, 2, and either 1, 2, and 3, all of them are kind of like,
connected.
well,
They build on each other, right?
I guess I was going to say I think that all 3 of them could be like accessible, like you, but they're and they do connect in some way. But I think they're 3 separate lessons. Like you shouldn't try to, or at least I wouldn't try to hit all 3 in the same
Yeah.
lesson because they're going students,
They're getting confused.
especially like the level of understanding I see from the students right there. Like they probably have to focus on one at a time, right? Focus on triangle congruency.
Yeah,
Then
definitely.
focus on Pythagorean
Yeah.
theorem, and then focus on, you know, the
Area,
area formula.
yeah.
And I think if you try to connect them together, like if a lot of students kind of already had an understanding, you know, and you just wanted to connect it together,
That's
but I
right.
don't think that students have enough of understanding to connect it. I think you're gonna have to like hit each one of them separately. And if you try and do all of it in one lesson, it'll be like too many moving parts, and students will get confused.
That's true. So I'm looking at this on number 5 where it says the height divides a big triangle into 2 different right triangles. That's what they were doing.
Uh-huh.
They didn't know what they were doing.
Yeah, no.
Yeah, like
I
that,
would-
that connects to this, obviously,
I
but
would
and we
not.
do that eventually. But
Maybe stick with 1, 2, and then
Yeah, I mean, like here, not a single student when they put the X and the H in the right places.
Yeah, no.
Like
I
they're
think only
putting
1 or
H on
2.
the hypotenuse instead of the height.
yeah.
So which student words should we use for? So we agree 1 and 2, or 1 or 2, or 2 only. What do you think?
Yeah, I defer to Castro. What do you think?
And I like both, but yeah, they would get confused because they're 2 different things.
I mean,
if I had to pick with the most important one that I know I can foresee them that they need more help with is number 2.
Number 2.
Just because it shows up so much, and that's one thing, one common mistake that even like top students make, like for some reason misunderstandings with the Pythagorean theorem. Because we do have questions where they do have to prove,
Yeah.
like is it a right triangle?
You could do this as a homework, like just discuss it. How could you prove it? Like this idea of justification, and that connect to number 2. Like, how could you prove it? Like, what are things we know about right triangles? Like, it's the right angle. What else do we know? Hopefully, it's the Pythagorean theorem. But this idea of proving things, like justifying, I think both of them they completely miss.
Well, they're used to proving stuff because that's what we did last year. So.
Yeah. But that is up to you. But are you planning to just do this a little bit, or are you spending? If you spending the whole class time, I think you would have time for 1 and 2.
Are we giving them back to them to correct or no? Or to try?
I think so. Like after the lesson.
Yeah.
Yeah, we can. That can be their exit ticket.
And just focus on one
Maybe
question,
2.
right?
Yeah. Or 2.
I mean, if you think that you can do 2, I was saying 1, but if you think, I mean, it's your class. You
Maybe
know
if
the
you
basic
cover it
work.
here, like you said, like a warm or like to open it with this, prove that whatever sides.
Like, how could you
Yeah.
prove it?
Because they're really good with the triangle congruency theorems.
Yeah, and I think y'all can. On one, it may just have been like they misunderstood the question, right? But once they understand what you're getting at, and then they can see from Rosaldo's point of view, like, oh, no matter how you draw it, the triangle always comes out the same, and then you can tie it back in the SSS. That.
Oh,
and
yeah.
if they're familiar with
I guess it just depends on the type of problem.
that probably wouldn't take too long to do that. So you could do that and then spend the bulk of the time on 2. Is that what you were suggesting?
So like,
Yeah.
is it a math talk?
We could. Well, we can choose the work, and then once we choose the work, we can see what it'll need to do. What student would you use for the first question? There's one, at least one that was close and one that way off.
I mean, to be honest, I didn't see any that was very close.
No. Maybe close was Mariana, like in a way, but she put the wrong word.
Yeah, I still have the same value as
So-
long as it's 3 7.
Because there wasn't a single student could disagree, was there?
No, not a single one.
So I think this one was the only one that I was like, how could we prove him wrong? Like, if you draw a triangle that has all the same size just in a different way, you'll get a different triangle. I think that's what I was trying to say. So will it be a different shape? That's the only one that
I
like.
wonder if they're getting thrown off because a lot of times in the last unit with triangle congruency, on their test they would have triangles. Like let's say they have this one and then a smaller one next to it, but it would be labeled like let's say this is 13, the other base would be 13 as well. But because it was smaller, like I was trying to get them into the habit of focusing on the measurement. So I wonder if he's saying like just draw it in a different way, but say it's the same measurement.
But I think here, for example, she said in different size, but this is a different shape. So they're thinking, oh, we're scaling, we can scale it down.
Yeah.
But this isn't saying, this is saying if you know all the 3 lengths of the size, you can still draw triangles that are different in shape. It's like, okay, if you know all 3 lengths, does the size change? Does this ever say that the size changed? No, it said, can you change the shape? Like if you have the same size, the sides, the lengths. So I think just clarifying that, like, will that change the size? No, it'll still be the same size. Yeah, that was hard, because not anyone got it.
Do you have to show student work for this one?
Oh, I guess you
Does
can
it be
create
a
it.
general, like just, I mean, a general, I mean, they all got it wrong, so. And they all pretty much, well, not all of most, but the same type of explanation.
Yeah, they're saying, oh, you can change, basically they said you can change the size of the length to draw a new triangle. I don't know.
No, I would say it's up to you if you think it's
Or maybe
beneficial, like first, to generate student thinking and deepen understanding. And there's work to show that. I mean, generally there is, but like in this case, I don't know.
I think
Or
maybe
at
this
least-
one,
or that one.
this was like a reading comprehension more than anything.
Yeah.
Maybe we could do like a 3 reads and don't, instead of student work, let's read it the first time, what is it saying in your own words? Read it a second time, what's the math behind it? Maybe some of them might be able to say, oh, like, congruency, maybe not. And the third one, what's that last, like what questions can you ask, or maybe the last prompt can be like, how can you prove this? What are some ways you could prove this? What do we know?
Yeah, I mean, you could just give them that prompt. Maya said the windy and then the sentence and have them discuss what it means, because I think there's a lot of confusion about what that even means.
Yeah, I think just a 3
And then
reads.
having the discussion on just the prompt and then at the end bring in the question and see what they say.
Yeah, that's probably the best thing.
So no student work, just 3 reads. Okay.
And I think that you're going to hear some kind of interesting stuff from our students.
Okay, let's move on to the second one. Any student work for the second one?
Someone could disagree with the answer, but their reason was terrible, I think.
I mean, this one it says yes because it has a 90-degree angle where the 13 and 20 centimeter sides touch. which is not correct, but then, I mean, if you wanna show that, then you could, follow-up prompt could be, well, how do you know that's actually a 90-degree angle, right? And then like just say, well, cause it looks like it's, or put a box there. So that one may be beneficial.
Cause like these two put no, but they put, there's no 90-degree angle, so they're looking for the symbol.
Yeah, and this might also be, I mean, I think that might be, you could show that, either one of these, and then a follow prompt question could be, well, how, like, do you,
How do you know?
yeah, how do you know,
Right.
right? And so, and then that would generate some
Cause like
discussion
this
about.
too, she drew it out and labeled correctly. I mean, you would think it's common sense, cause they know 21's longer. So is that possible that helps too, cause they know how to correctly make the triangle? Or if they did it up here, like labels, that way they know, okay, which one's the hypotenuse. You know what I mean?
Yeah, I mean, I think all these are, have enough substance to them that you could share in one of those three and there'd be some conversation about it. Cause yeah, this person's saying, essentially that just because there's one side that's longer, that the longer side has to be the hypotenuse. And that's, you know, maybe that.
Cause they have to identify what the parts are.
Yeah, but then that's not necessarily true, right? Just because you have a right triangle, the longest side isn't automatically the hypotenuse, and then I think showing that would then generate some discussion on what actually does the word hypotenuse mean. Is hypotenuse just mean the longest side of any triangle,
Yeah.
right? And then I'm sure that will bubble up some misunderstandings or misconceptions that could be discussed.
Yeah, cause the only time they saw hypotenuse in unit 5 was when we were dealing with the hypotenuse leg theorem, and almost everybody was like, what is a hypotenuse? What is a leg?
Yeah.
So I had to I'm like, well, time out, like this show really quick what it is. And it showed up in the notes where it's like, okay, hypotenuse is the longest side, even though it's not always gonna work. And they're like, well, what's a leg? So they didn't know the parts of a triangle.
Mm. Could you take a picture and send it, and I can add it to the slides?
Are these 3?
Yeah, whichever one's better. So which, I guess.
We want 3 or we want 2? Well, either one, these are the same, right?
No, this one,
Oh, that one's different. This one, right?
I mean, they're kind of opposites. This guy says no because there's not a 90-degree angle. This guy says yes because there is a 90-degree angle, without either one really saying how they knew if there was or wasn't a 90-degree angle. So I mean, you can include,
Oh, sorry.
Maybe this
I
one.
don't know.
And this one.
So many though. So I think we got like 6 minutes left.
Do so.
Third period, yes.
That's good.
Next door. So what would the prompt be for this one?
For the student work here,
We could ask, what was does this solution make sense? Or is this a convincing argument? How could it be improved?
yeah, is this a convincing argument? Why or why not? I mean, cause for that one, for the one where they said no because it's,
Because the right triangle has a 90-degree.
yeah, that should say, no, that's not very, it's true, like it's a true statement, but it's not convincing, cause it doesn't
How do
really,
you-
like how do you know that this doesn't actually have a 90-degree angle? Like you didn't prove it or explain it.
I think the question would be, what do we know about 90-degree triangles that could prove it? Or how could it improve?
Yeah, or what fact about 90-degree, or what fact about right triangles could you use, or something like that? What fact about 90-degree, or what fact about right triangles do you need to apply?
Oh, that's true.
Or what fact about 90-degree angles is helpful?
What facts do we know about right triangles that could help us? Yeah.
Okay, I just sent you the 2 pictures.
Okay, I'll add it. And then so we picked the prompt. Do you wanna do, I wrote, are they used to like think, pair, share for the 3 reads? Or, cause this is what I have, what is this question asking in your own words? Would that be like a write, pair, share, or think, pair, share for the 3 reads? Or just think, pair, share?
Maybe think.
Yeah.
Yeah,
Yeah.
we're used to those, that's probably the most common thing.
So maybe like think, what is this really question asking your own, give them time to think, pair, and then share it out. And then the second one would be, what math concept is this question referring to? That's where I'm thinking they might be like, oh, congruency, hopefully. No. If not, you can ask questions there, like, what have we learned that is related to 3 sides of a triangle, 3 sides of a triangle.
Yeah, and then talking about, the question says, are they different in shape, but then that also,
That means
are
congruent.
they
Yeah.
different or the same, or what do you call it when things are the same shape? And,
Especially if you say
the
proving,
vocab.
like if you say like to prove that those 3 sides are the same,
Yeah.
immediately once you say prove, I think they'll start saying the theorems.
Yeah, so the last one,
Okay.
I just wrote down the question, like, do you agree or disagree with me? I'll explain why you agree or disagree. And that way, I think someone can say it out loud,
Yeah.
the answer. And then for this one, for question 2, I just wrote, is this a convincing argument? Why or why not? How could it be improved? What facts do we know about right triangles that could help us prove it if it is or isn't? I think that one would be a good, what's it called, where you, gather stuff and write it down on a poster. I forgot what it's called.
Comparing or
Collect and display. Like, what is everything we know about 90 degrees, and then Pythagorean theorem should come up there. I'll just write collect and display. And then is the goal for them to actually try Pythagorean theorem and see if they can prove if it's 90
I think
degrees?
so, yeah.
Okay, so once you have, I guess the next prompt would be,
Would they have the same one and just prove it?
yeah, like show
Just
how
be
you
the
know.
question.
Using, like the goal would be that they say Pythagorean theorem for number 2, and then you go, I guess that part. Do you think it's worth like you doing it first, or should someone do it first, and then once someone figures it out, give them time to struggle and kind of guide people, and once they figure it out, have them explain it, that way everyone can see it? Or would it be, if no one gets it, then you would show it?
Yeah, I think that would be like just wait to see what they give you.
Yeah.
And then I have a feeling no one would do it.
Oh, you never
like
know.
outright, but
I think I get it. I think if once you say Pythagorean theorem, like, oh, I don't know, maybe I'm hopeful.
well, no, that might be good. Yeah, once you say it, and then they're like, okay, I know it's a squared plus b squared equals c squared. I don't think they'll know. Some might not know. Okay, what is a? What is b? What is c? And they'll show you some math.
Is there a picture where someone labeled on the sides?
Yeah, I sent it to you.
Okay, perfect. I'll put that on slide 3. That way it's like obvious. Oh.
That'll be
Yeah.
good.
And then for the exit ticket, I guess it's we can choose them to just correct 1 and 2.
Yeah.
Right. Okay, that's it. Adding it to the exit ticket for me, but I'll send it later. It's basically a little survey that says like, how do we do in terms of depth?
Do we fill it out from the document or write it in?
You can write it in the email. I'll just send
Oh,
this.
it was an email?
Yeah, you can type it. Cool. Thank you guys.
Diana,
So-
when are we doing this?
Tomorrow.